Thank you guys for coming out here today. My name is Joshua Burgeon. That part I did not forget. I am the general manager for the EC2 Spot business. Also, my team is responsible for scheduled reserved instances. And I'm here to talk to you today about how to get the most out of EC2. So this is a deep dive across our purchasing models. I hope you're in the right place. If not, we close the doors, so you have to stay. All right, what are the purchasing models that I'm talking about? So I'm going to start at a really high level, dive deep into EC2 background information, and then kind of come back to these. So there really are three from a fundamental perspective. There's on-demand. Most of you are hopefully familiar with this. You pay for compute capacity when you need it. No long-term commitments, no upfront payment. There's reserved instances. If you make a commitment, you can receive a significant discount, and as well, you get reserved capacity. And then there's also Spot. I mentioned I'm the GM for Spot, so it's near and dear to my heart. You can bid on unused on-demand capacity, and there's a market price model where the price fluctuates based on supply and demand. So AWS, a little bit of background. All of these things are based on EC2, so I think it's helpful to kind of step back a bit. How does, oh hey, that's great. You guys doing okay back there, everybody? I can do it without the notes, but not the slides. All right, so how does cloud computing help the enterprise? It's pretty simple here, right? Faster time to results. This is what it's about, whether it's faster time for you to get results or faster time for your customers to get results. Lower total cost with pay-as-you-go pricing. No more massive capital expenditures up front and data centers with low utilization. We're elastic and we're powerful. Now, what that means is you can both scale up, but you can also scale down. One of the dirty hidden secrets of on-premise data centers is how much compute capacity is just sitting around idle because you have to guesstimate how much you're going to use. And then these three things on the bottom are kind of fundamental underpinnings of AWS's value proposition. We are globally accessible. That means close to you, close to your customers. We are secure, and we are scalable. If you think about scalable, that means effectively, it's limitless capacity. What do I mean by global? This is a slide we use a lot. There are over a million active customers across 190 countries, over 800 government agencies, although those of you who paid attention to the keynote, this number is now 2,000. So I need an elastic slide service. These things are out of date the minute we print them. 3,000 educational institutions, and right now we operate in 12 regions. And again, like I said about the slide, there are 4 more announced regions this year. In each of those regions, we operate 1 or more availability zones, and we also have 54 edge or point of presence locations all around the world. That's what we mean by global. This is truly massive scale. When I talk about a region or an availability zone, it's important to kind of understand what those concepts mean. They don't always necessarily translate exactly one-to-one into the traditional data center world. So a typical region might look like this. This is an illustration only. So you have a mesh or multiple availability zones. I mentioned these before, and also transit centers. There are redundant paths to each of the transit centers, and the transit centers connect to the public internet, privately, peering, all kinds of models here, right? What's an availability zone? Good question. So an availability zone, and I mentioned there are 33 of them worldwide. They have all regions have 2 or more AZs for high availability, redundancy, and each availability zone is 1 or more data center. So again, an availability zone is not a single data center, it's 1 or more. No data center is in 2 AZs, we don't split them that way, and each of these data centers have redundant power, redundant network. So again, even within a single availability zone, you're getting not only a lot of capacity, but a lot of redundancy, a lot of availability, a lot of power. Now I'm going to offer you a little nugget if you're ever in Seattle at some kind of trivia night that AWS happens to host. If you need to answer how big is a typical data center for AWS, the answer is 50 to 80,000 servers. This was referenced on one of James Hamilton's blogs a little while back. Why is this important? Well, it turns out that if you have a very small data center, you've just paid a huge amount of money to get started, and you've gotten relatively little benefit. As you get bigger and bigger, that scale starts working for you. All of those investments you've made in real estate and planning and server acquisition and landing those racks and turning servers on and the power and the redundancy, that starts to work for you more and more. But it turns out those economies of scale start to peter out at a certain point. And really huge data centers, you get declining return. So these are some of the advantages you don't have to think a lot about, but I want you to know that AWS is thinking about them on your behalf. Now, inside of each of those data centers, there's lots of things happening, but one of the most important ones, in my opinion, is that there's all these EC2 instances available to you. So we have many EC2 instance types, and this is not a deep dive on them. In fact, the presentation about that was just minutes ago. So if you were there, that's great. If you missed it, you can catch it on YouTube later. So we have all these different kinds of instance types, and in each instance type, there's different sizes of each instance. So you have your general purpose ones, your storage optimized for, your GPU optimized for deep learning or machine learning or big data, your compute optimized workload, workhorse instances, C3, C4. These are our acronyms. You don't have to like them, but they're ours. And the power of this with all of these different instance types is that we fit your workload rather than the other way around. You don't have to fit yourself to the way we think of things, and you don't even have to fit yourself to a single instance type. You can say, I need a lot of storage, I need a lot of memory, I need local storage, I don't need any local storage. This is really powerful, and we're going to go into this a little bit more. Also, I would be remiss if I didn't talk about how seriously we take security. So we've architected our security to satisfy military standards, global banking standards, and the regulations that govern other highly sensitive organizations. Some of you may be working for one of those organizations right now. Some of you might not. So why should you care? Well, the benefit is when we're thinking about the intersection, the union of all of these different requirements, you can be assured not only are we thinking about it 24/7 by 365, but you're benefiting from it all that time. What does this look like in practice? We have the largest amount of accreditations and certifications of any cloud provider out there. One or more of these is probably applicable to you in this room. If it's not, you're still benefiting from all of the requirements that we must meet in order to get these accreditations and certifications. But you don't have to take my word for it, which is good, because you don't know me. Right, here's a quote from a customer. You can trust him. He wouldn't say this otherwise. So Rob Alexander, CIO of Capital One. This is a really important point. Here he's saying not only is the AWS secure, but in some ways, AWS enables them to operate more securely than they would in their traditional data center. And we think that's really powerful. And also, like I said, you don't have to take my word for it. Here's Forrester Research, which is an independent research organization. And they put AWS in the leadership position in terms of public cloud platform providers' security back in 2014. Who's using AWS? Again, all of you are either using AWS, thinking about using AWS, thinking about how people use AWS, helping people move to AWS. The number of customers, as I mentioned earlier, over 1 million, 190 countries, but it's truly staggering how many enterprises and how many industries are coming to AWS for all the awesomeness, whether it's Netflix encoding and streaming videos and original series, whether it's FINRA or the SEC doing big data analytics, whether it's Capital One, Intuit. I mean, the list of names goes on and on and on. That's why we throw these slides up there to give you an idea that AWS isn't just for startups. It isn't just for big enterprises. It's for everybody. So with that in mind, how do you optimize EC2 in general? So there are 4 pillars we'd like you to kind of think about. We're going to focus most on the purchasing option pillar, but there are really 4 of them. So you can see them here, right-sizing the purchasing options and kind of leveraging them together. Thinking about elasticity, both in terms of scale up and down. And then lastly, continually measuring, monitoring, and improving your optimization. So, like I said, purchasing options are going to be the bulk of our presentation, but I'm going to go through briefly how you optimize across these other 3 pillars. So what is right-sizing? Remember all those instances I mentioned? We also have lots of services you might avail yourselves of. You want to select the cheapest instance that meets your performance requirements. Do you really need 32 cores? Can you take advantage of that? Do you scale across 20 gigs of RAM? If not, why are you picking that instance? You're just throwing money away. This is actually some of the things where you might learn not to necessarily take all of your application developers at face value. One of the great things about EC2, like I mentioned, is you don't have to think about it a lot in advance. You can get started using Spot. You can get started using OnDemand. See how your application performs on different instances. If someone says, I don't know if I can use a T2, my instance needs much more CPU, give it a whirl. You'd be surprised. Elasticity. A lot of us tend to think of elasticity as scaling up. I've got a big spike in demand. I need to launch more instances. That's great. EC2 is really good at that. We have lots of services that can provide horizontal and vertical scale. But what about scaling down? Do your developers work after 6 p.m. or 7 p.m.? If they don't, why are you running their instances? Does your demand shrink in the evening? Why are you buying reserved instances for all of that demand? You can use auto-scaling to scale up and down. You can get very granular with this. In fact, the journey we see a lot of our customers on is the smarter they get about that fourth pillar, which I'm about to talk about in terms of measuring and monitoring, the better they are able to kind of set up metrics that their auto-scaling groups can scale up and down based on. I mean, the cheapest server is no server. And I mentioned this, measure, monitor, and improve. This should be part of your practice. And by that, I don't mean you spin up an entire department to monitor and improve AWS usage. What I mean is you avail yourselves of tools that we make available to you or our partners. Tagging is a great one, and I'm going to talk a lot about this. Tag your resources. Identify the things that are always on that are not production. Do you have dev and test environments that should only be running an hour or two a day? Don't run them 24/7. Right? That's a super cheap non-technology optimization. Downsize. You can use tools like Trusted Advisor or partners such as Cloudian, Cloud Health. They'll help recommend RIs to purchase. You can use your dashboards. You can take these reports and kind of report them back to your bosses, hopefully, kind of justify your investment there. And then I want to talk a little bit about the pricing principles. So I've just said, hey, you're going to measure, you're going to monitor, you're going to improve. Well, one of the cool things is the way our pricing models work, typically with no upfront investment, you can immediately put anything you learn into practice. So let's say you learned you have hundreds of instances doing nothing in the evening. You don't have to wait till the next purchasing cycle or the depreciation is complete to kind of get rid of those instances. You can turn them off. You pay less when you reserve. As you get smarter about knowing what do I really use all of the time, you can save significant amounts using reserved instances. And I think a little bit unique to our DNA and the way we think, you will pay less the bigger we are. We've had 50 price cuts since 2006. So we've taken our size and acted in a customer-obsessed way, as we are prone to do, and passed those savings on to you. What does this look like in the real world? So I want to take an example from Novartis. So they had an existing on-premises grid, it's fixed size, like most people have data centers. They're not infinitely elastic. And one of their scientists, or a group of them, had an idea that they wanted to screen, they found a molecule they wanted to screen 10 million compounds against for a cancer target. They estimated the new infrastructure to support this initiative would have cost $40 million to build. Can you imagine being the scientist walking up to your IT guy and saying, hey, got a great idea, it's an experiment, no idea if it's going to work, 40 million bucks and I can do it, right? Thumbs up, everybody's going to get 40 million bucks, right? No, that's not what happened. So they come to us and they completed all of this research using, they call it 39 years of computational chemistry. They did it in 9 hours, and they spent $4,200. Not a math expert, but that's kind of less than 40 million. But the more impressive thing is the 9 hours piece, right? So they didn't just say, okay, I want to spin up another 5,000 node grid. That's what I can afford. Maybe I can afford $10 million, and I want to take a year to get the research done. Even if you can say yes, you don't always say yes to the whole thing. But the power of AWS means you don't have to have that kind of computation in your head. All right, so that's the background on AWS and EC2 and kind of how we look at the world. Now I want to dive more deeply into the purchasing models. I mentioned them before. There's only 3 of them. Hopefully you haven't forgotten. On-demand, reserved, and spot. What is on-demand? I mentioned this. It's low cost, it's flexible, turn it on, turn it off, no upfront commitment. It's really great for develop and test, especially when you're getting familiar with AWS, or if you have short-term, spiky, or unpredictable workloads that can't be interrupted. We'll talk a little bit more about what those workloads might be, but this is how you use OnDemand. The great thing about OnDemand is this is the only slide I'm going to have to show you about how it works, because there's not a lot to figure out. Then we have reserved pricing, or reserved instances. These are fantastic, of course, for steady-state workloads that you can predict. You get reserved capacity, and we've mentioned this. We have the always-on reserved capacity, and also a new product called scheduled reserved instances for sort of partial day or partial week workloads, still with the same sort of 1 or 3 year commitment. And you can, if you choose, use upfront payments to further reduce the cost. How much do you save? Up to 75% off of the on-demand rates, which is significant. So you get the capacity reservation. You can save up to 75%, depending on whether you use no upfront payments, which would be the least savings, or all upfront payments where you're kind of paying for your reserved instance completely in advance. That's the most savings. Commitments exist in 1 and 3 year increments, and as well, we have some flexibility on selling your RIs on the RI marketplace. And then the last one, which is my favorite, of course, EC2 spot pricing. I love them all. They're all my children. This is the best one. So spot pricing, how does this work? If you are time flexible, can you start later? Can you finish later? Are you instance flexible? Does it really matter that you're using a C4 extra large? Could it also be a C3 extra large, or an R3 or an M3? Maybe you could use a G2 if one's available. You might not think to do that because you've optimized your workload a specific way, but on spot, because of the way the pricing works, you're going to get an advantage if you can be instance flexible. Are you doing an experiment? Maybe this experiment has unclear ROI. Maybe you're Brookhaven or Fermilabs. You're trying to explore the origins of the universe, doing 50,000, 100,000 core workloads from data coming out of the Large Hadron Collider. You're not going to spin up a whole data center to do that. That's an experiment. This is the kind of thing that can make that possible. Or maybe you've built a really cost-sensitive business where every fraction of a penny is the difference between whether you're profitable or you go out of business. It's kind of a big incentive to use something like Spot. And lastly, do you urgently need the computing right now? Does somebody else in your organization urgently need it right now? Do you need large amounts of additional capacity that you wouldn't otherwise be able to afford? As an example of what we mean by large amounts of capacity, there are more, people are using more Spot right now, on average each week, than were running compute jobs across all of EC2 in 2012. Pretty big. Why would you use Spot? Big number, 90% savings. You want to save up to 90% off the on-demand price, you should be looking at Spot. 90%, pretty good deal. If you can't visualize what 90% looks like, it's about 1 cent per core hour. Or if you're thinking really big, that's a 10,000 core data center for about $100 an hour. Think about what your best people could do, or the performance you could add to your website for just pennies. We've also added innovations like Spot Fleet. This does the undifferentiated heavy lifting of managing a heterogeneous instance fleet, replenishing your instances if they get interrupted. And we've also added Spot blocks for people who say, I'd love to use Spot, but I really can't afford any kind of interruption. We have these Spot blocks where you specify a duration, and you still save 30 to 50% over the on-demand price. So these are for workloads that must run continuously. And there's no commitment. Turn these on, turn these off. You can burst often significantly higher than you can with on-demand. So how does this work in practice? One more slide on Spot. Spot is, as I said, a market for compute where the price changes based on supply and demand. You will never pay more than your bid. If you're familiar at all with auctions, like an eBay auction, you have the bid price and then what you end up paying. This is probably one of the most misunderstood things. So if you take away nothing else from this presentation about Spot, like pay attention right now. So this is the market price. This is a publicly available tool about our price history. It's available by API. It's available on the console. You pay the market price. Here, the example is I'm paying 20 cents an hour. That is an 87% discount for this particular instance size over the on-demand price. 87% sounds really good, right? I'm paying the market price. Now, what do I bid? How does that work? A lot of people say, well, I really want to save a lot on spot, so I'm going to bid 25% of the on-demand price, really low. I never want to pay more than that. It's okay, you can do that. So this person bid 25% of the on-demand price, and every time you see this black line cross over the green line, that represents a time when the price in the market went above what this person was willing to pay, and their instance was interrupted. So they were interrupted a few times. They saved 86%. Seems like a good deal, right? I'm going to change it up a little. What if I bid 50% of the on-demand price? I only got interrupted once. My savings went down all the way from 86 to 85% with no extra effort. I've only lost 1% of my savings, but I've avoided a few interruptions. Take it a step further. What if I bid 75% of the on-demand price? Well, I can't guarantee this. This person, over 7 days, faced 0 interruptions, saved 84% off the market price, and they're still using Spot. So the simplest thing you can do to get started with Spot, bid the on-demand price. It's just like using on-demand. You'll never pay more than on the on-demand price. Typically, you'll save up to 90%. You might see in the 80% off savings. No work to avoid the interruptions. Maybe you have to restart your job or architect a little fault tolerance in. But you do not need to become an expert on markets and auctions and bidding to get started with Spot. You can use Spot Fleet with multiple instances. You can bid the on-demand price, and you'll still save significantly. All right, so let's put this together. Which one is right for you? We actually think that's the wrong way to look at it. Picking only one is like picking a single food that's your favorite and eating only that food for the rest of your life. Now, there's probably somebody in the audience who's like, I love that. I drink Soylent. I don't know about the rest of you, but a balanced meal is what sounds good to me, right? The balance is going to look different for each of you, and that's what we're going to spend the rest of the presentation talking about. So you don't have to choose just one. In case you're wondering which one represents Spot, whichever one is your favorite. So use a combination. I mentioned this, right? You're going to use reserved instance for your steady state and known workloads. You're going to set up multiple scaling groups. Auto-scaling makes this really easy. You can set up one for your on-demand and reserved instances, one for Spot. You can scale using Spot, on-demand, some combination of the two. There's really no reason for you not to be doing this, especially if you think across multiple different kinds of workloads that you have. So I'm going to go through 2 examples in terms of application frameworks, and then a little bit more about how this looks across different industries. I'm going to start with a 3-tiered web app. And this could really represent any 3-tiered application that has a stateless front end. So what you see going on here is we have incoming HTTP traffic routed by an ELB or an elastic load balancer to multiple different availability zones, each of them running a stateless front-end web tier. And what I mean by stateless, right, is the responses are handled very quickly. They don't store the user data. We're treating these EC2 instances as cattle, not pets. So that means if one of them goes down, we don't really feel very bad. We can simply replace it. I should have mentioned this earlier, but the Spot instances have a 2-minute warning. So if you think of a stateless front-end web tier, you can actually drain from the ELB, handle all the connections that are on that Spot instance, fire up another one, and be done without your users even noticing. In the middle here, we might have an application tier that's a cache or some other performance layer. Maybe that's a little more stateful. And then on the back end, we have our relational databases. Again, using RDS, for example, to span multiple availability zones gives us high availability, good performance. So your application might not look exactly like this, but I'm betting it's close. When you have a web app, you're going to think about optimizing for performance first, availability, and then cost. Right? You want your users to have the best performance. As an example, Amazon.com a while back found that a 1-second increase in latency in terms of website response would cost them $1.6 billion a year in sales. So I'm sure you have an analog there that you think about too. So how are we going to do this? I mentioned tagging. I'm going to hit this point home a lot. You get 10 tags per instance, Tagging is free, takes a little bit of effort, but then you're done with it. Everything good comes from tagging. Please tag things. Tagging allows you to explain the costs, allocate costs to the right team if that's what you do, or at least help you understand how you would allocate costs across different tiers, and give you opportunities to save money. Tags are very simple. They're key value pairs. It's metadata that you attach to an instance. You might tag with who launched the instance, or what group it belongs to, or what part of the tier, or is it production or test. And you can combine these things in all kinds of really cool reports. A lot of our reports and a lot of our partners' reports are built on top of these. Again, 10 tags per instance. You can do whatever you want with these. So how do I use this? I've tagged my web tier. It's stateless, and I'm going to scale based on the incoming demand. So I know I have a certain amount of demand that I'm going to have any time of the day. I never go down to 0. So I'm going to use reserved instances for those. Really not a lot of thinking involved in that, just good savings and no orchestration. Then, because this is stateless, as I mentioned, I'm going to scale using Spot. I'm going to take advantage of multiple different instance types that are very similar. Maybe I'm even going to overscale. Does that sound weird? Remember what I said, like turn off instances that aren't being used? But what if you're saving 90% off of the price? Why not scale up a few extra ones and shave off some milliseconds from everybody's website experience, right, from their latency? Why not scale up in advance of demand? This kind of flips things upside down. You would never do that in your traditional data center, but you can do that using Spot. And lastly, maybe I'm going to top up using OnDemand here. So then my app tier. This is going to look different, right? Remember I said this was stateful, at least to some degree? So I'm going to be running, again, a whole tranche of reserved instances to serve my steady state. And then because this is stateful, maybe I don't think this is a good application for Spot. I don't want to re-architect my application to handle constant node failure or worry about that even. So I'm going to use OnDemand, typically, for the next amount of the peak. Again, because I am the GM of Spot, though, I'm not going to get off this slide without mentioning, you're going to use Spot blocks for your 1 to 6 hour jobs, maybe for that last little bit of peak that you only see infrequently. So there's always opportunities for you to be saving costs, even when you have a highly steady state workload that's stateful. Then there's the database tier. I will say this at least once in every conference. Although I am the Spot GM, if you run your database on Spot, I will hunt you down. You laugh. People have done this. Do not do it. I disclaim all warranties if you do. You're going to run your databases on reserved instances, and the reserved instances are going to be static at your peak load. That's for performance. It's for availability. It's the right thing to do. However, there's still an opportunity to use the elasticity of the cloud to your benefit. Let's say you're running your databases here, like I've pictured, but at the end of the week, or the month, or the day, you have all these reporting jobs. The typical posture in an on-premises data center is to say, well, let's oversize the database, or let's slow down the performance of these ETL jobs or analytics. Nobody's satisfied by that, right? You're either spending more money than you need to for load that only comes once a week or once a month, or you have these really slow ETL jobs. I feel like at every company I've ever been at, there's these ETL jobs that fail because we have to cut them off by 8 in the morning when the new load comes into the database. You don't have to do that with AWS. You can snapshot or back up your database, run it on an on-demand instance, fire up a bunch of Spot instances to run the ETL jobs or the analytics against it, turn them all off. That's really like a really powerful thing. So I don't want people to miss it. So even when you're running a really steady state workload that's totally stateful, the elasticity of the cloud allows you to do things you would not be able to do in your on-premises data center. So remember when I tagged everything? Maybe one of the tags I used on every node is website, right? Across my test, my prod, all 3 tiers, I used the website tag. Here's the balanced meal, what it looks like across all of my tiers, right? I'm using 76% reserved instances. That's good, saving a lot of money. I'm using 13% Spot. Maybe that's mostly concentrated in the front end, the web tier. And then I'm using 11% OnDemand. These are not prescriptive numbers. These are just an example of how you do things. Although this is really awesome, I would love you to optimize using EC2. There are other ways to save money. Werner Vogels, CTO of Amazon, is fond of saying, no server is easier to manage than no server. And what he means is not what I said earlier about turning things off. What he means is using things like Lambda, SQS, SES. You can hand over the undifferentiated muck of managing all of that to us and simply scale up and down and get your responses dealt without even managing any of these servers. I hear of some enterprising startups moving entirely serverless using nothing but Lambda, which sounds kind of crazy to me, but I love that people are innovating like that. How does this look in the real world? I'm going to use one example that's very similar to something I've experienced in my career. So Ubisoft is a gaming company, for those of you not familiar with them. They launched 10 social games within 18 months on AWS. There's no heavyweight procurement process, no thinking about data centers, no thinking about infrastructure. I mean, is Ubisoft an infrastructure company? No. They're in the business of making awesome games that people love to play. The reason this is important is that our CEO of AWS, Andy Jassy, is fond of saying, invention takes two things. One is the freedom to innovate, and then the second is not having to live with the consequences of those failures. So you're not going to launch 10 games in 18 months if you're really afraid that one of them is going to tank $5 million of your investment. You're going to be a lot more cautious. I actually worked at Zynga most recently prior to Amazon, and I was there for when we transitioned away from AWS, and interestingly, as they've transitioned back and gone all in. Here's another example in terms of application frameworks. It's a very broad area we call grid processing or batch. Again, your architecture might look different, but what you're going to see typically in grid processing is you're going to have what you're seeing pictured in the bottom left are a whole bunch of files. Maybe they're large files, maybe they're small files, maybe you're storing them in S3, maybe you're storing them in a POSIX-compliant file system such as EFS. Then you have a grid, which is, in this case, EC2 instances, coming together to work on all of those input files, process them somehow, combine them, chew them up, spit them out, map reduce them, whatever it is that you're doing, and then you spit them out. You could spit them out into a database. They could end up on S3. They could end up post-processed into other files that another grid processes. This is a very common architecture. We see this a lot across every industry. When you had a grid historically, this is the only way to make sure you had enough compute for all of the actual demands you have on the way in. So you had to acquire servers predicting in advance exactly what your peak would be, and you actually had to acquire more than that, right? As you can see here, let's pretend the actual demand for computing is going up. Probably not pretend, probably what most of you are experiencing. So I would have to acquire servers in advance and more than I need to make sure that I was always ready. Now, I don't know about you, but in IT, I never see this. This is actually, why don't I see this? All of that unused IT resources. Nobody wants to have a whole bunch of servers sitting around doing nothing most of the time, just in case there's a huge peak coming in. This is what we actually see. You're still acquiring servers in advance, but you're only acquiring them for the most profitable or persistently predictable workloads. So you see all those peaks that I shaved off? Do you know what those represent? Delays. Now, the good news is I haven't wasted any money. So I could simply take this model and use it in the cloud. This is very simple. If you have incredibly predictable workloads, you can simply buy 3-year reserved instances and just keep stepping that up as the demand increases. There's nothing wrong with this, but again, you're going to have the same problem that I talked about. Central IT, though, is probably pretty happy. They're measured by how much is my grid used? What's my utilization rate? Maybe they even have a goal, maintain 90% grid utilization across the year. I'm trying to get that blue line, that jagged blue line, as close to the top of this as I possibly can. That is not how it looks to your business users. Your business users, when they experience a full grid, they have jobs in the queue. These jobs represent work. This is work that they can't get done, or experiments they can't run, or reports they can't finish. So you have a mismatch in the goals between the people who procure the infrastructure and the people who are using it. It's exactly the opposite of what people want. The cloud is different. You can have scalability when you need it. You can accelerate projects. You never have to shave off those peaks, nor do you have to waste money scaling in advance of when the peak demand happens. So you can respond flexibly and quickly for new demands to computing. Let's see how that looks. So this is an example. I took the same kind of utilization that we saw before and said, look, I'm going to have some steady state utilization. For those, I'm going to buy 3-year RIs. Really good cost savings, a lot of predictability, low orchestration overhead. Then I'm going to take my non-fault tolerant workloads, maybe ones where there's high justification for getting them done. They're going to use on-demand. No re-architecture needed. Just get them started on on-demand. Let each business user fire them up. But everybody else who's screaming at you, or maybe just screaming out silently, you're going to give them access to Spot. You might say, but I'm a traditional enterprise. My jobs aren't fault tolerant. I think you would be amazed at the ROI for throwing a couple developers at Spot and fault tolerance when there is 10,000 core data centers for $100 an hour. People move pretty fast when jobs that have been sitting in the queue for weeks or months typically, or maybe never getting processed, can suddenly get done. We see this a lot. You are unlocking your users to operate at the speed their business needs to operate at. You can take it one step further. This is the great thing about innovations. We listen to our customers. People said, I love Spot. What about if I really need some surety? Well, we added Spot blocks. I mentioned these earlier. It's a single parameter in the Spot API. You basically say 1 to 6 hours, exactly how long you want them to run for, and then you save 30 to 50% off of the on-demand price versus the higher savings for Spot. And you can maybe shave off a little of that on-demand usage. So over time, you're going to get more and more mature, and your usage is going to look more and more like this. So why does that matter? It doesn't matter because I'm up here to talk about it. It matters because of what customers say. I really love this quote. This is a huge corporation, right? 15,000 people, tons of divisions. They're no longer constrained by IT or infrastructure or the speed of their business processes or the inelasticity of their data centers. They're only constrained by their thought. Now, I don't know about you, but you probably have a line inside your corporation that says, people are our biggest asset. That's what this is about. It's taking your best people, your smartest people, or people you want to hire, and telling them they're going to work in an environment where they're not going to be constrained. That's the power of the cloud. That's the power of EC2. So how does this look across different industries? I'm sure there are many represented here today. I'm going to start with an example I mentioned earlier, sort of ad tech. For those of you who might not be familiar, you have billions, trillions of ad impressions being served every day. Typically, they start out as a request for a web page. This goes through an ad server. Let's use one with real-time bidding or a mediation layer. We have customers processing 50 billion ad impressions a day in under 100 milliseconds, where they're going from request to decision, or to evaluation to decision and serving it back up. So the great thing about that is it has to be very fast. They have to scale very high. The peaks are unpredictable and spiky, but they're also stateless. If a request has to be served in 100 milliseconds, a 2-minute warning for a Spot instance termination is a lifetime. You can serve a whole bunch of requests, 20 of them if they were sequential, and then turn off your Spot instance and nothing happens. We typically see things that look like this. So here you have a customer using a significant amount of Spot. Let's look at the exact inverse of that. This is an enterprise SaaS company. Maybe they built their product 10 years ago, 15 years ago. Maybe it's a giant monolithic application. That's fine. Maybe they're really lucky. They sign contracts with customers that enable them to predict 1 or 3 years in advance exactly how many servers they need. You might see them making almost exclusive use of RIs That doesn't mean they're inelastic. Again, we allow you to purchase the RIs in real time, exactly when you need them. Maybe they're using on-demand for a proof of concept on a customer site or for testing out a new model. And in this case, this person's using maybe a tiny bit of Spot to do some analytics or dev test workloads. Another interesting model is what we call the onboarding enterprise. So this could be any kind of company that's moving onto AWS and thinking about how do I use it, and maybe they're building new applications. So they start out using a lot of on-demand, trivially easy to get started, no application constraints, pick whatever instance you want. Start firing up some RIs once they move these applications more fully. And what you see here in this example is somebody's built a new application. It starts out with very little demand, and then as you can see, the on-demand usage grows, and it grows, and it grows, and at some point, somebody comes along and looks at all those tags that I mentioned and says, hey, new app, why are you using so much on-demand? It looks like you've really taken off. And that person said, oh, you're totally right. I was just experimenting before. I didn't know. Boom. They buy a bunch more RIs. And they've saved a lot of money. But they didn't have to do that planning in advance. If this new application didn't take off, they simply shut it off. A more specific version of an enterprise, and I've mentioned Ubisoft and Zynga, is a gaming company. Games are in the hit business. They're trying to make new hits. It's a lot like entertainment industry. So this is an example where we have maybe a large gaming company. They've got a stable of 5, 10, 15 games. They're running those all on RIs. They've got a persistent workload, or persistent amount of load. What happens is they get up to a new major release. Maybe it's an expansion pack for an existing game, or maybe it's a new game. You see the load start to increase. And here it's all in on-demand. Then what you see is a massive spike. Maybe the game went viral. Maybe they didn't predict the load. Maybe this was entirely what they predicted. In any case, they were able to spike up really quickly. When then demand sloughs off, they end up at a new normal. So what you see in the new normal is they've purchased a little bit more RIs, but not necessarily as much as they needed to hit that peak. Right? So this is the power, even when you are in an unpredictable hit-driven business, of being able to handle all the load and not worry about this. It's really huge. Now there's two more here. Scientific research. This one's a little bit misleading. If you looked at this, you'd think they're not using very much EC2, and then suddenly they use a lot of Spot. Another way to look at this is this person has a 5,000 node grid. It looks really tiny, right? You see the giant little tiny orange line? Let's pretend that's actually 5,000 cores. Then all of a sudden, a scientist comes along and says, I've got a grant. I've got $100,000 I can spend. I need to run a 100,000 core workload for a week. And you say, yes. You say, yes, you can use Spot. That's perfect. It's $100,000 for a week, 100,000 cores. All of a sudden, this person launches 20 times the amount of compute that you've been using the entire year. You get a graph that looks like this. So those are real-world examples. That's what happens, right? You can get a graph that looks totally distorted in terms of your usage, but it doesn't blow your budget. Then this person turned it off. We don't have a problem with that. We also have, as I mentioned earlier, very many large enterprises, tens of thousands of people, multiple divisions, multiple countries. They might look a lot more like this technology company here, this nameless one that I've listed over here. They have a huge base of RIs running SAP and Exchange and all of the back office functions. They've got a lot of on-demand perhaps for their smaller analytics workloads or their web tier, their app tier, and then they're using Spot for experiments, dev tests, big data analytics. This is actually what we see a lot of times in the long run, is that people end up, no matter what industry they're in, looking a lot like this technology company. So I've spent a lot of time talking about different industries, but I don't want to leave you with the impression that you're going to look exactly like any one of them. You're going to look like this. Every function inside your company is going to have a different pattern across these three purchasing models. If you're a data science or you have quants, they're going to love Spot. Real-world example is someone who came to us, a friend of mine, and said, I really love EC2. I'm using R. I'm running an M4.4. It's really cool. I can just turn it on, turn it off. My job runs in 30 minutes. We're like, oh, that's really cool. Have you tried an M4.10? And he said, I don't want to pay for that. That's a lot more money. I said, well, no, it's not more on Spot. It's actually less than the M4.4 and OnDemand. Fires up an M410 using Spot with his R workload, writes me back and says, my job finished in 3 minutes. I think he was reasonably happy. So we find this pattern a lot in data science, right? Internal IT looks totally different. Your internal IT, I mentioned these CRM workloads, ERP, they're going to be running heavily on RIs, and if they're very stateful or monolithic, you're only going to scale up and down using OnDemand. New app development, I mentioned this earlier, new app. It's probably trademarked. This person is experimenting. They're firing up a new application environment. Maybe they've got a small amount of users. It's going to look like this. When it takes off, we probably cut off this graph a little too soon, you're going to buy some RIs for this person. And then test and development. We've seen an increasing trend where continuous integration or continuous deployment workloads are moving to Spot. These workloads often finish in 30 minutes or less. They benefit from parallelization. And if they get turned off, your real end users aren't affected. You can kind of turn them back on again. So what we see here is a customer who, over time, has increased their Spot usage, increased their on-demand usage, and then at a certain point decided to buy RIs to save money on that on-demand usage. You may not have exactly these functions, but time and again, what we find with people on their journey to AWS is as they move all in, this is what they look like. So I want to recap. Remember those 4 pillars of optimization. These are going to apply no matter what purchasing model you're using. They're some of the simplest ways to save money. Right size. Don't use a bigger instance than you need. You would be surprised, especially with enterprise applications, how little CPU some of them actually use. Increase elasticity. I've talked about spinning things up when you need them. Turn them off if you don't need them. It sounds like it goes without saying, but you'd be surprised again how much things are just running all the time, because in a traditional data center, there is no incentive to turn things off. Measure, monitor, and improve. And by that, I don't mean that each of you should spin up a measure, monitor, and improvement department. We give you tools. Our partners give you tools. We have Trusted Advisor. These are things you can automate. This should be part of your practices, but it's not something that you're going to have to spin up a big department to replace your DevOps people. Use tags. I mentioned this. Tags, tags, tags. I don't get a kickback. They're just good. 3 core purchasing options. Spot, reserved instances, on demand. Have a balanced meal. Always be looking at your workloads and architecting them with this performance and cost in mind. As you get less monolithic, more cloud-friendly, you will definitely find yourselves with more opportunities to optimize, more opportunities to use Spot, and I think smarter use of resources. Before I get to the last slide, I wanted to give you a little anecdote. I started working at Amazon originally in 1997, the beginning of the year, when Amazon was a tiny bookstore and there was no AWS in sight. We had 1 web server, so 1, not like an offline, not like a test one and a real one. We had 1. So when we wanted to change the content or the software, we would flip a symlink. Sounds like laughably primitive now, right? But that was because we bought the biggest server we could afford because we had no idea what the load was going to be, and we couldn't afford another one. So we had 1. I was part of an enormous, what felt like enormous team that came up, where it was given the task of, okay, we have 1 web server, we now need multiple web servers. That's not going to scale anymore. There's no bigger machine. We literally had the biggest machine. So we were going to go from 1 web server to 4. It's huge. And this was still in 1 country with 1 product line with books. That project probably took, I don't even remember anymore, dozens of people, hundreds of person hours, thousands of person hours. I knew it was at least 6 months long to not only figure out what servers we were going to buy them, to procure them. Oh wait, we're out of space in the machine room. We had to go get another machine room, a real data center. I actually moved these servers in my car down the street. Before that, they had like tarps over them because there was rain coming in. And not only that, but we had to build all of the software that I was talking about today. There was no ELB. There were commercial products. We had to go buy those, figure them out, understand them. There was no Docker. There was no Puppet. There was no Chef. I don't tell you this to say that I was awesome. The software we built was, again, laughably primitive, but we were constrained on our ability to serve more customers for Amazon.com, which was growing like a rocket ship then, just like it is now, based on the infrastructure we had and the software that was available. I would have killed for what we have inside AWS. Not because it's really cool and I work for AWS, but I could have done so many more valuable things than sitting there figuring out, how do I keep 4 web servers in sync? How do I flip symlinks all at the same time? How do I roll back? You don't have to worry about it. This is the glorious age of cloud technology right now. You don't have to live in that. Not only that, things like Spot weren't even a glimmer in my eye. I couldn't have possibly imagined not having to plan in advance for a 100x spike in traffic. I can't count the number of what we used to call Sev1s when the whole website went down because some enterprising marketing manager launched a new sale via email for a book, right? We used to talk about the Oprah effect, if you guys remember the Oprah's book club. That would take the website down. These things are long since the long thing of the past, right? But I talk about this kind of stuff because across every industry, you can use EC2's purchasing models to give you an enormous amount of freedom. That freedom makes you more cost-effective than your on-premises environment, both in the short term and the long term. If you leverage the EC2 consumption models, the different purchasing models I mentioned, if you follow these patterns, you have the freedom to build unfettered. You can tell all of your people to go. The infrastructure is no longer the constraining problem. You get real value from your data. We've talked a lot about cost, but what about accelerating innovation? Why are you holding people in a queue? Why are you telling your best people, sorry, no? I want that data now. I want the analysis now. I want the information today. My users on the website want a faster experience. Ultimately, that boils down to the freedom to say yes. So when we look at these 3 freedoms, we think of that as kind of the power of AWS. I hope what I've done today is hammer home that EC2 is one of the core pillars of these 3 freedoms. Thank you very much. Really appreciate your time here. I hope it's been educational. We do have evaluations outside. I have a little bit more time for questions if anybody has them. But again, thank you very much.